And these examples here they're about to work on, these are working in reverse. I'm going to give you the graph of the polynomial, and you have to work backwards to give me the equation. So in all the other examples so far that we've done, I've given you the polynomial, sometimes factored, sometimes not, and you would have to sketch the graph of the polynomial using your knowledge of end behavior, x and y intercepts, and your multiplicities. So now we're going to work backwards and use that information from the graph to find the equation. So in this first example here, we'll call this p of x for polynomial. I have, if you look, 1, 2, 3 x-intercepts. So I have an x-intercept at -4. Now that means I would have a factor of x plus 4, because if I plug in -4, I want to get out 0. I also have an x-intercept at -2. So that means I have to have a factor x plus 2. So when I plug in -2, I get out 0. And then the last one, for the last intercept, I have an intercept at 1. So that means I have to have a factor x minus 1. So when I plug in 1, I get out 0. Now, I also have a leading coefficient. I'll call it a. You can call it whatever you want. But I don't know what that is. We're going to find it. Okay, and then one other thing that we're going to do is we got to find the multiplicities for each of these x-intercepts. At -4, it crosses straight through the graph. So that would be a multiplicity of 1. At -2, it also slices straight through the graph. So that would also be a degree of 1, or a multiplicity of 1. But if you look at the x-intercept at 1, it does a touch and turn. That means 1 should be a multiplicity of 2. It should have 2 factors. So I'm going to put 2 up here. Okay, now we're almost done. The last thing we have to do is find our leading coefficient. Now, to find our leading coefficient, all we have to do is plug something in for x and y so we can solve it for a. So pick something on your graph that crosses nicely, that's easy to read, and plug it in for x and y. It doesn't matter what point it is. Just pick one that crosses nicely. For example, I don't want to pick this point here where I just drew in red, because I can't tell if that's 2.3 or 2.1 at 32. You want to pick something that crosses exactly at the cross of the grid. I personally like to use the y-intercept if that's available, because that makes me plug in 0 for x, which makes the arithmetic easier. So I'm going to choose the point 0, 8. So I'm going to plug in 0 for x and 8 for y, and then I can solve this for a. Okay, so I'm going to have, when I do this, 0 plus 4 is 4, 0 plus 2 is 2, -1, 0 minus 1 is -1, and -1 squared is 1. So I have 4 times 2 times 1, so that gives me 8a, which means a has to be 1. So my final answer for this would be p of x is equal to 1, which is my leading coefficient, times x plus 4 times x plus 2 times x minus 1 squared. And if you want to check to make sure you have the right equation, you can plug it in on your calculator and verify that you get the same graph that's on our worksheet here. Okay, next example. On this one, we only have one x-intercept, it's at 1. So there's our leading coefficient. At 1, that means I should have the factor x minus 1, because if I have an x-intercept at 1, I want to be able to plug in 1 and get out 0. Because it does a touch and turn at 1, this should be a multiplicity of 2. So I should have a 2 up there. So I should have an x minus 1 as a factor twice. And now I just got to pick another point on the graph so that I can find out what my leading coefficient is. So here was my x-intercept, and I'm going to pick my y-intercept since it's available and I can see easily what it is. It makes the arithmetic easier to use stuff with zeros in them. I'm going to plug in 0 for x and -1 for y since I picked 0, -1. So -0 minus 1 is -1, and -1 squared is +1. So I get a is -1. So my final answer is going to be p of x is equal to my leading coefficient, which we found was -1, x minus 1 squared. And this makes sense. You can always go back and make sure this makes sense too because of your end behavior. Since I have a leading coefficient that's negative and I have a degree that's 2, my arrows or my end behavior should be in the second and the fourth quadrant. This is a quadratic that has a frown shape. It's facing down. Okay, last example. Let's see, I have 1 and 2 x-intercepts. So I have an x-intercept at -4, which means I should have the factor x plus 4 in my polynomial. And then I also have x minus 0. You can write it as x plus 0 too if you want. It doesn't matter because it's 0. Whoops. Now, at -4, it doesn't slice straight through the graph. It does one of those swirly things. So this is going to have a multiplicity of 3. And at 0, it slices straight through the graph, so that's going to have a multiplicity of 1. Another thing, too, you don't have to write x minus 0 in there if you don't want to write the 0. X minus 0 is still just x. So you can actually write it like this as well if you'd like, just times x. It's up to you. It's more of a preference. It doesn't matter. So now let's pick an extra point on the graph that we can use to plug in for x and y so we can solve for a. Now keep in mind that when I'm plugging a point in for x and y to find a, don't repick your x-intercepts. That's going to cause a problem. Make sure you pick a different point. So I can't pick my y-intercept in this case because my y-intercept and x-intercept is the same. So I've got to find another point on the graph that crosses nicely and is easy to read. So it looks like this would be a good one to pick for my xy, -2, 16. So I'm going to plug in 16 for y and -2 for x. So I have -2 plus 4. That gives me a plus 2, and 2 to the third power is 8. So I have 8 times 8 times -2. So 8 times -2 gives me -16. So I have 16 is equal to -16a, so a has to be -1. So my final answer is going to be p of x is equal to -1. That's my leading coefficient. X plus 4 to the third times x, or if you want to write it as times x minus 0, that's fine too. But this would be your final answer. And again, you can check to make sure that it makes sense with your end behavior. This is a degree 4 because I have a cube times an x to the first. That would be a 4th degree. So it's even degree with a negative leading coefficient. So both my arrows should be facing down in the third and the fourth quadrant, and it does.